All right, so this is day 2 of our first week of notes via the video. So this involves a little review from the algebra that you did last year, so just to kind of get you familiar with how it's set up. So these are notes, and this is from the algebra module 2, topic 2, lesson 3, and this is technically day 2 of it. Okay. All right, and we're still dealing with Alan and his sales of popcorn boxes. In this case, they need to be, he needs to make a deposit on the trip, and it needs to be at least 1,100. So if you remember yesterday, or in the previous notes, we had the equation f of b is equal to 3.75. I kept goofing up on that. I kept putting 3.25. So if you wrote down 3.25 on yesterday's notes, make sure you fix it to change it to 3.75. Not that it's that big of a deal, because this again is just kind of practice, but little mistake. All right, so in this case, they need it to be at least 1,100. So if you notice, they've set up the inequality to where the inequality has to be greater than or equal to 1,100, so that 3.75b plus 25 is greater than or equal to 1,100. And then they go through the process just like with an equation with the properties of equality, subtracting 25 on both sides and then dividing by 3.75. And they get an answer of 286.66. Well, that's a correct answer. There's nothing wrong with that answer. It's an accurate answer. But can you sell a 0.66 part of a box of a popcorn? You can't. So they're wanting to know how many boxes does he have to sell. So again, you have to think through, how am I going to answer this? And it would be 287 boxes. Because if all he did was sell 286, that would be under that 1,100. It'd be like 1,099 something, not 1,100. So he'd be really close, but wouldn't quite be there. Okay, so make sure that you check not just in how to solve the inequality or equation, but also what type of an answer they want. All right, so we're going to go through and do a couple of these. So what's the greatest number of boxes that Alan could sell and still not have made 600? So that means he's under $600 in sales. So that means the sales, the amount of boxes, has to be under making a $600 in sales. So we're going to go and we use the 3.75b plus 25, and it has to be less than or equal to, or just under, because it can't be equal. So it's just going to be less than 600. And then we go through the process of solving it. So just like they did on the worked example, you subtract 25 on both sides. You get 3.75b is less than 575. And then you divide by 3.75. Now you may not need to show all this work. Just depends on how comfortable you are with solving inequalities or equations. We're not dividing or multiplying by a negative, so sign stays the same. And we get an answer, if you grab your calculator, of 153.33. Well, again, that's a partial box. So if in this case, if we round up to 154, then he would have made at least 600, maybe even $601. So this would be 153. This would be an example of where you round down based on what you're trying to get for your answer. Because we don't want to make 600 in sales, we want to make less than 600 in sales. Now, at least how many boxes would Alan have to sell to make 1,500 in sales? So here's where the at least is coming in, whereas before, still not or no more than 600 in sales. So now at least, so that means we want to make more than 1,500. So again, we're going to use that 3.75b plus 25, and that we want it to be greater than and equal to. In this case, we're happy if it's 1,500 as well. Okay, and then the same process, subtract 25 on both sides. You get 3.75b is greater than or equal to 1,475, and then divide by 3.75. Now, showing work in geometry is kind of an interesting thing. There's times where you really need to show work or explain yourself. There's other times where you don't need to show so much because it truly is all just calculator stuff. So in this case, we're still kind of doing a little review from algebra. You might want to just show your work. You may not need to show the division, but you still need to show the subtraction just to get you to that first step or that next step of the division. Totally up to you on which way you want to go with that. So you get B is greater than, grabbing your calculator, 393.33, repeating. And you might be thinking that, oh, okay, this is a 0.33, so I'm going to have to just round down again. But now, if we round down to 393, we will not have made 1,500 in sales. We will have made 1,498 in sales or something like that, but we will not have made 1,500. So in this case, even though the numbers are below 5 and rules of rounding say to round down, or keep it as it is, I should say, we are trying to make 1,500, so we want to sell 394 boxes. Now, we've done these all in this y equals mx or ax plus b thing. So how does it change if the inequality is in a different form? It doesn't. You still have to sit there and get your variables to one side and your numbers to the other. So a real quick example, if you had 3x minus 5 is greater than 2x plus 8, you still have to get variables to one side, numbers to the other. So in this case, I would add 5 to both sides and get 3x is greater than 2x plus 13. Subtract 2x. Now, some of you may say, well, I would have done the subtracting 2x first. That's fine. Doesn't matter which order, if you get the variables to the side first or if you get them to the side second. You get x is greater than 13 for your final answer. The process, it doesn't matter what you do first or what you do second as long as you follow the properties of equality. All right, reversing the inequality signs. So this is where it kind of comes in. Students always get thrown off. When do we switch the inequality sign? Basically, I just kind of talk about how when you divide by a negative, you're taking the opposite of everything. You're taking the opposite of the x. You're taking the opposite of the whatever you're dividing into. If it's a positive, it's a negative. If it's a negative, it turns into a positive. So you also have to take the opposite of the sign. This little example here kind of shows a little bit more as to why it works. So we're going to kind of run through this one real quick. We now have the camping troop. They're hiking down from a campsite at an elevation of 4,800 feet to the base of the mountain, which is at sea level, and sea level is at 0 feet. They hike down at a rate of 20 feet per minute. So notice down is an important thing. So we need to write a function h of m to show the troop's elevation as a function of time in minutes. Okay, so that means height in minutes is equal to, we have our good old-fashioned, don't forget, whoops, let's put it in function notation. So f of x is equal to mx plus b. M is our slope or our rate, and b is our y-intercept or our starting point. So in this case, we're told our rate is 20 feet per minute, and we're going down 20 feet per minute. So it's going to be negative 20, and in this case, m is our variable they want us to use. And our starting point is where the camp is at 4,800 feet. Okay, we need to label. So we're going to change the y here to h of m. We're going to change the x here to m. We need to identify the independent and dependent quantities. So again, remember the independent drives it. In this case, what's driving it? Well, the rate that they're going down or the time. To descend. And it's in minutes. Our dependent depends on the independent. And that is going to be our height. And that is in feet. All right, so we need to analyze the function and identify each characteristic. So again, we have our function up here. I'm just going to write it over here so that we can see it and not have to go back and forth. So negative h of m is equal to negative 20m plus 4,800. All right, so our slope, again, is our rate. So our slope is negative 20. Okay, it means the rate of descent, and it's in feet per minute. Okay. Our y-intercept is where we're starting. That's where it crosses the y-axis. That's at 4,800 feet. Now our x-intercept, you kind of see it right down there at the bottom. They're going to be asking for it. X-intercept is where it crosses the x-axis, and it looks like it crosses about right there. So our x-intercept is actually at 240 minutes. And what does it mean? That's when they reach sea level. Okay. And the domains of the function, that's all the possible x values. So all our possible x values of this are from 0 minutes, because you can't go back in time, okay, to 240, because I don't think you want to go under sea level unless your base camp is, I guess, under sea level, because there are some places that are. So our domain is between 0 and 240. Now these square brackets, don't know if your teachers taught this last year, that means that it includes that value. Round brackets don't include it. So it's kind of like a greater than equals to and that sort of thing. So it goes from 0 to 240. And different teachers teach a different way, but that's the domain there. Okay, and so domain is the time it takes. So 0 minutes to 240 minutes, so it looks like it takes about 4 hours. All right, so we're going to use the graph. So I've kind of copied the graph from the previous page to determine how many minutes passed if the troop was below 3,200 feet. So we kind of need to look over here. 3,200 feet looks like it's about right here. So on the graph, it looks like it's there. It asks us to draw an oval to represent this part of the function. So kind of talking about this part right here. And write the corresponding inequality statement. So we have the negative 20m plus 4,800. Okay, and this is when it's all below or equal to 3,200. Okay. So we just wrote the inequality to verify the solution. So it looks like if we kind of go down here, okay, looks like that it's 60 to 120. So it's going up by every 2 is 40. So it looks like it's about 70, 80 minutes or so. But we want to know for sure when they're going to hit it. So another way we can do it is to actually solve the inequality. So let's go through and solve this. So we have negative 20m plus 4,800 is less than or equal to. So let's go ahead and subtract 4,800 from both sides. We get negative 20m is less than or equal to, so 3,200 minus 4,800 gives me negative 1,600. I'm going to divide by negative 20 on both sides. And because I'm dividing by a negative, I'm taking the opposite, and so I get a positive m. Negative 1600 divided by negative 20 is 80, positive 80. And because I'm dividing, I am going to swap that symbol. So that means that it's actually closer to 80. So mine was off a little bit here for the 3200, maybe a little high, maybe it's closer to down there. So that's where you can use a graph, but being able to solve an equation gets a little bit more accuracy. All right, so graph is good for a quick visual. Function get more accurate of an answer. And they could, I mean, they're supposed to be exactly the same, but again, the graph depends on how close and that sort of stuff you get. All right, so then they're asking us to complete the table. Okay, so again, we know that at 3,200 feet, it's 80 minutes. So when h of m is equal to 3,200, then that means m is equal to 80. When h of m is greater than 3,200, so if we take a look here, when it is greater than 3,200, so it's kind of like this part up here, which corresponds with this part down here, then that means m is less than, m is less than or equal to 80. And when it's just greater than 3,200, m is less than 80. So when h of m is less than 3,200, so going back up and looking at the graph here, we're looking now at this area down here. When it's less than 3,200, that means that it's in this part of it. That means that it's greater than 80. That means m is going to be greater than 80, and m is going to be, whoops, greater than or equal to 80. Okay. All right. Sorry, it keeps jumping around like that. All right, so what do we notice? Well, we notice that when they, the inequality signs change. All right, and why is that? Well, it's because when you're multiplying or dividing by a negative, we had a negative slope. So the inequalities, they switch. Switch, how about we try that? Switch or become opposite. Become opposite. Why? Well, when you multiply or divide by a negative numbers, you have to flip the signs, flip the symbols. Okay. All right. And we're done with those notes. Okay. All right. So the next thing you need to do is wrap it up and make sure that you've got all the information. Have a good day.